Okay, now we have the A bar delta V delta T triangle. This is much less intuitive, much more confusing. It got Aristotle, although if I had explained this to him, if I could have spoken his language or he mine, he would have grasped it and all of its implications and within 2 or 3 seconds known it better than I do. But he was really smart, okay? But it didn't occur to him. He didn't quite get there. This stumped Aristotle. It's not obvious. It's not intuitive. You cannot rely on intuition like how fast is how far divided by how long. Or your equally good intuition that if you multiply the average velocity by the time interval, you get the displacement. Here, you have to have the definitions, and the definitions I choose are the ones that go back to the rate of change definition, because the rate of change definition is applied again and again and again in this course, in this whole idea, in the development of Western civilization. It's extremely important. So, people want to tell me, and people pretty much know, that average acceleration is delta V over delta T. But they want to write V average over delta T. That's a very common error, okay? And don't see the difference because its symbols are really quite similar. And if you're just looking at symbols, that's really easy to do. And that makes it really confusing. And if you don't understand the meanings at the level of the rate of change definition and the definition of acceleration, you're not going to get it. Okay? So, why is this true? Because the average acceleration is the average rate of change of velocity with respect to clock time. Now, I didn't complete the thing because you're supposed to have completed this, and I expect you to do this. And if you can't, then let me know and we'll go into it, but we've already talked about it. So go back and look through the documents I've asked you to work through, and I'm not sure everybody's worked through. And even those who've worked through maybe should have worked through in a little more detail with a little more attention to their errors as evidenced by the difference between their solutions and the given solutions. We really need to understand this, okay? All this is a simple change between this definition and the definition of average velocity. Average velocity is average rate of change of position with respect to clock time. Here it's the average rate of change of velocity with respect to clock time. Instead of change in position, it's change in velocity. Now there are a lot of implications to that, but you don't begin sorting through those implications until you have the definition straight. So the definition is not this. Definition is it's a rate of change, and you apply the rate of change definition, and then this pops right out. And of course, this is very similar to this. Very easy to confuse also with this. Very easy to put a V bar in here instead of an A bar. Okay, I've seen that one this morning a couple of times. Okay, if you're thinking in terms of the definition and working from the definition, you will not make a mistake in writing this out, at least not if you're practiced in using the definition and use it carefully. And at very least, you're much less likely to write this thing down wrong, much less likely to mess up. Now, the other relationships here, how do you get delta V from A bar and delta T? Here's delta V, delta T. How do they give you A bar? Well, you multiply both sides by delta T. You multiply the acceleration by the change in clock time, and you get the change in velocity. Not the average velocity, the change in velocity. Be careful. And then how do you get delta T if you know the average acceleration and delta V? And you're going to divide delta V by the average acceleration. And it all follows very simply if you know the algebra, and you got to be careful to know the algebra. Right here it is for V bar, delta S, and delta T. Multiply both sides by delta T, and you got one of your relationships, the one for delta S. Or up here, multiply both sides by delta T, and you got the relationship for delta V that allows you to get delta V from these two. And then take that Down here we took that relationship and divided by divided by V bar, and we got the solution for delta T. Well, we can do the same thing up here. Having solved for delta V, we can then divide by A bar and get our relationship for delta T. So this mimics this, but it has a completely different meaning, tells you something completely different about motion. I'm repeating myself all over the place, but you have to understand this based on the definitions. That's the beginning of understanding how to analyze uniformly accelerated motion, as opposed to plugging numbers into meaningless formulas, which is a good skill to have, even if it is meaningless, but it doesn't take you far enough. It doesn't give you the complete picture, and it doesn't provide a building block for understanding later topics in physics. Understand these definitions, and you'll have a really good foundation for later work.